In the next few videos, we're going to look at the theorem of Pythagoras, which you would have seen with me in many forms at this point of your studies. We have a triangle here, A, B, and C, and the two straight sides squared and added together is equal to the diagonal squared. So if we're looking for the diagonal, we can just say that C is equal to the square root of A squared plus B squared. If we're looking for one of the straight sides, let's say A is equal to the square root of C squared minus B squared, and B is equal to the square root of C squared minus A squared. So these are the quick ways of just jumping into Pythagoras' theorem without worrying too much about what theorem 14 states and its converse, which is number 15. You can pause the video and give this a read if you want and have a look at the diagrams here and the squares that appear on either side. But we're going to jump into some questions just to see how easy Pythagoras is when you know the quick way to read the question and look at the solution. So here we're looking for the straight side, so we can say x is equal to, now you'll know the answer here is 5. You should know this triangle like the back of your hand at this point. So x is equal to mathematically the square root of 13 squared minus 12 squared, which is the square root of 169 minus 144, which is the square root of 25, which is 5. But you've seen this 5, 12, 13 triangle many times at this point. This one here, 12, 16, we're looking for the diagonal, so x is equal to the square root of 16 squared plus 12 squared. X is equal to the square root of 256 plus 144. X is equal to the square root of 400. So x is equal to 20. So if we imagine this triangle just getting smaller, let's say we half all these sides. Let's say we get a 10, a 6, and an 8. Does it still hold true? Is 10 squared equal to 8 squared plus 6 squared? Is 100 equal to 64 plus 36? 100 equals 100. So yes, it does hold true. Well, what about if we half it again? We get our 5, 4, 3, this triangle that we see appearing. Okay, let's have a look here. We're looking for the diagonal. X is equal to the square root of, now you could say the square root of 11 to be squared, but at this point you could just write 11 here plus 5 squared. So x is equal to the square root of 11 plus 25. X is equal to root 36, which is 6. Just be careful here which one is the diagonal. Is always opposite the right angle, the longest side. We're looking for the diagonal. X is equal to, I'm just going to write the 15 this time, plus 7 squared, which is 49. So x is equal to root 64, which is equal to 8. Down here we've 2 that we're looking for. We can definitely get this x first. X is equal to the square root of 4 squared plus 7 squared, which is equal to the square root of 16 plus 49, which is root 65. Does ask us to write a third form where necessary. Now your calculator will simplify this for you, but if a square number divides into it, it will simplify. But you can see here 4, 9, 16 don't divide into 65, so it won't simplify any further. So now we're looking for y here. We're looking for the straight side, so we just say that y is equal to the square root of the diagonal squared, which was the x. So 65 minus 8 squared, if you want to write it like that, or you could put in log form root 65 to be squared, and that's going to be the square root of 1, which is equal to 1.